Hello, students, and welcome to our lesson on simple interest. Simple interest is going to be the beginning of our financial portion of the class, and essentially, it's the building block of all the other financial formulas we're going to talk about. So, before we can talk about compound interest or mortgages or anything like that, first we need to just understand what is simple interest. So let's dive right into it. What is simple interest? Well, interest in general can be thought of as a fee. It could be charged to you on a loan, so that would mean you pay it to the lender, or it could be earned on an investment, so that would be paid to you. So a fee doesn't necessarily mean it's a bad thing. Okay, interest could be bad. It could be money that you owe because you borrowed money, but it could also be money that you've earned by investing. So interest is a fee that could either be good or bad to you, depending on the context. Simple interest, which is the title of the lesson, simple interest is calculated once over a set period of time and usually applies to auto loans, short-term loans, or small investments like savings accounts. So simple interest, we really call it simple because it just happens once. That's the key. When we get to the next topic, which will be compound interest, that'll be interest that happens over and over and over again for some set number of times in a given period. But simple interest is simple because we just earn interest once over a given time period. The following formula can be used to calculate simple interest. We have that I is equal to PRT, okay, where we're multiplying together the letters P, R, and T. Let me space my T out to make it a little more clear there. All right, and so we need to know what each of these actually represents. Because this formula is to calculate simple interest, you can probably figure that I here represents the interest that is accrued. The letter P, this might be your first time hearing this. Usually in investment terms, we talk about principal. Okay, so P stands for principal, and this is the amount of money that you invest, or it's the starting amount of money for the loan or investment. So if you borrow money for a car, the amount of money you borrow is the principal, and then generally there's interest charged on top of that principal. Okay, but principal you can think of as the starting amount. Then we have the letter R, which is going to represent the interest rate, which is given as a percent, but is input into the formula as a decimal. I cannot stress enough the fact that we need to input it as a decimal. So we have talked about percentages in this class already, and all those same rules apply. Whenever we work with a percentage, we always convert it to a decimal or a fraction before applying it to any equations that we're going to be working with. So we always have to make sure our interest rate, even though it's given as a percent, we convert it to a decimal. And the last letter T, T is the most consistent one for most students, the one they like the best. T represents time. All right, so however long this loan is, that will be the time given. So now we can have different units on each of these. Principal, because we're talking about money, is almost always measured in dollars, but theoretically you could have it in some other currency. But given where we're based in this class, we're going to keep it in dollars. But the interest rate and the time, those can always vary. So generally speaking, we want the interest rate to be in years, and so we want the time to be in years also, but it's not always given to us in that format, and it doesn't technically have to be. But what does have to be true is that rate and time need to have the same units. So need same units. If we don't have the same units, then the mathematics we're doing doesn't make a lot of sense. So we need to make sure that whatever interest rate we have, if it's given in days or years, we need the time to also be given in days or years. And the way we'll handle this is we will just always match the time to the interest rate. So whatever units the interest rate uses, we're just going to make sure that the time has that same unit. So if the interest rate's in years, but the time is given in days, we'll convert days to years. And whatever other units we might have, we will always convert the time to match the interest rate. All right, and then we just want to make that note a little more explicit. by saying note that the rate and time can be yearly, monthly, weekly, daily, etc., but the units must match. Okay, so same point there, just doubling down on it. We absolutely need to check that our units match whenever we do these problems. All right, other than that, we're really just applying a formula. So we're gonna get straight into it. Depending on what we have missing, we will use the formula slightly differently, but we're gonna be using that exact same formula in all of them, I equals PRT. So for example number 1 here, we have that I has a question mark next to it. So that's the thing we're solving for. We have a principal, an interest rate, and a time. So all we have to do is plug in these variables to the formula I equals PRT. So I equals, and then we're going to plug in 2000 for P. We have to, oh, that says 200, plug in 2000 for P. We're going to convert 4% into a decimal. So 4% is equivalent to 0.04, okay, because it's 4 over 100. So I'm going to put in 0.04 for that R value. And then T is in years, and our R value is also per year. So before I plug in the T, I'm always going to check that my units match. So right here, interest rate is per year, and time is years. Because these are the same, I'm just going to take the 2 and put it directly in. But if I needed to make these units match, because if they were given differently at the start, then I would convert the time to start off. All right, now that I have it, I equals 2000 times 0.04 times 2. I can go ahead and just type that into a calculator. So 2000.04 times 2. I get 160. So I equals 160. And now we just need to make sure that we use appropriate units. Because we are talking about money here, we can go ahead and put a dollar sign on this 160, because what happened is we took $2,000 and we invested it at 4% for 2 years. So we would say that the interest we earned is $160. So our original $2,000, the fact that the unit there was dollars, is the same reason we have a unit of dollars here. All right, number 2, we're going to solve for a different piece of the puzzle. We now have interest is $288, principal is $1,200, our interest rate is 8% per year, and we are solving for a number of years. So when I apply the formula, we're going to have a variable for t. So we're going to have that the interest, which is 1,200, is equal to the principal multiplied by the interest rate, which we have to convert here. 8% is really 0.08 because we moved the decimal twice to the left. So 0.08. And then since we don't know what t is, we're just going to leave it as the letter t. So now we need to solve for that variable t. This is just a normal equation like what we've had earlier in the class, where if I multiply 288 times 0.8 real quick, so 288 times 0.08, that is 2304. Okay, so I can go ahead and multiply. Um, hmm, Something feels wrong. Oh, I see what's wrong here. I put a couple numbers in the wrong spot, guys. Let me backtrack. So the issue I made is I put the 1200 over here for the interest, but the 1200 needs to be on the other side. So let's do a little bit of erasing here real quick. So my interest needs to be on the left, 288 over here on the left, and then my principal, the 1200, needs to be over there on the right. So my apologies there. So now what I'm going to be multiplying instead is I'm going to multiply 1200 times 0.08. And when I do that, 1200 times 0.08, that gives me the number I was expecting, which is 96. So now this equation reads 288 is equal to 96 times t. And so now that we've multiplied the 1200 times the 0.08, now it should seem obvious that all we have to do is divide both sides by that 96, and then we're going to have the variable isolated. So all we're doing is isolating t like we would with equations in the past. So when I work that out, 288 divided by 96, I can go ahead and do real quick. 288 divided by 96 gives me 3. So we can go ahead and say that 3 is equal to t. And because t right here is measured in years, and we had per year as our unit, we can go ahead and say that 3 equals t really means 3 years is our solution. So in the first problem, we had $160 for as our interest, and now we saw that we can solve for time and that it takes 3 years for $1,200 to accrue $288 in interest. All right, now we're going to move on. In number 3, we have another easy one. When I say easy, I mean that we're solving for the interest. Because whenever you're solving for the interest, all you have to do is plug in the numbers in their appropriate spots. Number 3 is going to have one twist over number 1, though. So I'm going to set it up the same. I equals, we have 500 multiplied by our interest rate. So 3%, I'm going to turn into 0.03. But now notice, I can't plug in 6 for t because our interest rate is per year and our time is measured in months. So I need to make sure that whatever I plug in here has the same units as the R value. So in order to make 6 months be equivalent to years, I'm going to have to use dimensional analysis and convert. If I have 6 months and I want to convert it to years, I'm going to multiply by the fact that 1 year is 12 months. So then my units of months will cancel, and I'm left with 6 on top, 12 on bottom, gives me 1/2 year. Okay, so 6 months is equivalent to half a year. I think a lot of us probably knew that 6 months was half a year, but it never hurts to go through the official dimensional analysis steps to get there. So 6 months is half a year. So now for t, I'm going to plug in the fact that t is 1/2 or 0.5, whichever you prefer. All right, so now we're going to go ahead and just multiply this out. So we'll pull out our calculator. Whoa, didn't know I could zoom in on that. That was cool. So we have 500 multiplied by 0.03 for the 3%, multiplied by the 1/2, and that gives me 7.5. So my interest earned is going to be equal to $7.50. Because remember, since we have principal is given to us in dollars, that means that our interest is also going to be measured in dollars. So 7.5 is $7.50. All right, number 4, we're now solving for the interest rate. Okay, so we have interest, so I'll put 225 over on the left side. We have principal, so I'll put 1500 on the right. We have time and the interest rate are both measured in years, so I don't have to worry about converting the years. So I can go ahead and put my time variable in here as 5. But now for that interest rate, I need to think about what I'm actually solving for, because I can go ahead and put R right here to represent the interest rate, but I need to make sure that I know that that R value I just wrote down is not going to be the R value that represents the percentage. That R value I just wrote down is going to be the decimal version. So at the end, we're going to have to make sure that we convert this R value into a percent. Just like in all the previous problems, we started with a percent and we converted it to a decimal. We're going to have to make sure we convert this R value back to a percent. And the way you turn the R value into a percent is you multiply it by 100. So at the end, we'll just have to make sure to multiply by 100. Or if we wanted to, we could actually put R over 100 in right here for the R value. So we have two options. Either write in the R over 100 right away, or solve for the R value at the end by multiplying by 100. In this case, I'm going to go ahead and leave it as R, and then we'll solve for the percent at the end. So what I need to do here is multiply. On the right side, 1500 times 5 is going to be 7500, and we still have that R variable. So now we need to divide both sides by 7500 to get R by itself, just isolating that variable. So we'll do 225 divided by 7500. That gives me 0.03. So 0.03 equals R. So now we just need to make sure that we convert, okay, this R value actually represents 0.03 times 100, which is 3%. Okay, so we multiply by 100 to turn it into a percent. And because it's measured per year, we can go ahead and add our units. Percent per year. So just make sure, convert to a percent at the end. So convert to percent. Okay, very important that we don't leave it as a decimal, because if you said 0.03%, that means something very different than 3%, right? We'd be off by a multiple of 100. All right, a couple more examples. We're going to be solving for some different pieces of the puzzle here, or different, same pieces, but given to us in a slightly different way. For number 5, we're solving for interest, which means we're in one of the easy ones. Okay, we're missing the I component. But notice our units are a little funny in number 5. We have our rate is per year and our time is in days. So before we even start this problem, we're going to go ahead and convert our time to be in years, because we want our years, our rate unit, which is per year, to match our days. So in order to convert 65 days into years, I have to use the fact that 1 year is 365 days. So that is going to give me that 65 over 365 is the number of years I have, because the units of days cancel, and I'm just left with a number of years. Now, I could turn that into a decimal right now, but because we're going to be using our calculator in a second to calculate interest anyway, we may as well wait and plug it in all at once to the calculator. So we're going to go ahead and set it up as interest is equal to our principal, which is 890, multiplied by our interest rate. I still need to turn the interest rate into a percent, so 3.5% is 0.035 as a decimal. So 0.035 is what I'll plug in for R. And then my t value this time, I'm going to write as a fraction, 65 over 365. So just make sure that if you are going to turn that into a decimal early on, that you do not round the decimal. Okay, so that's why I'm leaving it as a fraction, is that way I don't round it midway through the problem. All right, so now we just need to go ahead and multiply this out. So we have 890 multiplied by 0.035 multiplied by 65 over 365. And that is all going to work out to be the interest rate is equal to 5, oh, sorry, not the interest rate, but the interest is going to be equal to 5.547. So I'm going to round that to be 5.55. And so we're going to say that the interest is approximately, since I had to round, I'm going to change my equal sign to be approximately 5.55. All right, so interest is approximately 5.55. Okay, number 6. We're now solving for principal. So when we set this one up, we're just going to have to make sure we put the blank in the appropriate spot. I'm going to go ahead and draw a vertical line here just to separate my two problems nice and cleanly. All right, so we have our interest is 6.75. I'll go ahead and put that on the left. We have that this is equal to our principal, which we don't know yet. So I'm going to put a big capital P there. We have our interest rate is 6%. I'll convert that to be 0.06 and plug that in. Okay, remember we're always converting percents to decimals. But then we have 3 months as our time. And notice that our interest rate is per year and our time is in months. So we want to go ahead and convert months into years. We've actually done this conversion already. We're going to do that 1 year is equivalent to 12 months. So I can put 1 year on top, 12 months on bottom. That means the months units will cancel. And we're left with 3 over 12, which is 1/4 of a year. So for my time variable, I'm going to plug in 1 over 4. You could of course use a decimal, but I'm going to leave it as 1/4 in this case. So just make sure that we're converting so that our rate and our time have the same units. So now we need to multiply 0.06 times 1/4. So 0.06 divided by, oops, not divided by, multiplied by 1 over 4. That gives me 0.015. So I can go ahead and say that 6.75 is equal to 0.015 times P. So then all I have to do is divide by that 0.015 on both sides, and I'll have the principal isolated. So now in my calculator, 6.75 divided by that answer we had before gives me 450 for the principal. So I can go in here and say that 450 equals P, and just clarify then that that unit on the 450 is $450 is the principal. So in order to have $6.75 in interest at 6% per year for 3 months, we need to have invested a principal value of $450. All right, now there's a you try. So if you haven't paused the video yet, please pause it and give this one a chance. All right, hopefully you gave it a shot. So we are solving for interest, which means it's one of the easier ones. And on top of that, we have our interest rate is per day and our time is also in days. So in the past, we've seen that all our interest rates were per year, but it doesn't have to be per year. All that matters is that the numbers, or the units, I should say, are the same in the rate and the time. So per day is fine as long as our time is also in days. So in this case, we don't have to do anything fancy. We're just going to set it up as interest equals our principal multiplied by our interest rate, which I just need to turn this into a decimal, so 0.014, and then multiplied by our time, which is 15 days. So we can go ahead and just plug this straight into the calculator. We have 25,000 multiplied by 0.014 multiplied by, let me double check, it was 15 days, so multiplied by 15, and that comes out to $5,250. So we can go ahead and say that the interest earned was $5,250. All right. None of those were too bad, I don't think. We had to do a little bit of unit conversion, but overall, pretty nice, clean answers. Let's go ahead and do a couple applications real quick. So number 7, it says a small clinic takes out a loan of $12,000 to purchase a new x-ray machine. The loan has a simple interest rate of 4% per year. How much interest will the clinic owe after 36 months? So the thing we're trying to find is the interest. So we know that we're solving for I. So I'll just set my equation equal to I, since that's what we're looking for. We have our principal was $12,000. We have our interest rate was 4%. So I just make sure to convert. 4% is 0.04. And then we have to be careful because our interest rate is per year, but we're given 36 months as our time. So we need to convert our time, 36 months, if we multiply that by 1 year over 12 months, then we can see the units of months cancel, and 36 divided by 12 gives me that this is 3 years. So for time, I'm going to plug in 3 because it's very important that we multiply by 1 over 12 to convert the months to years, because we absolutely need our units on rate and time to be the same. So now we have our interest formula set up. We can go ahead and pull out the calculator. 12,000 multiplied by 0.04 multiplied by 3 years gives us an interest amount of $1,440. So how much interest will the clinic owe after 36 months? They will owe $1,440 in interest. All right, number 8, one more. A dental clinic paid $1,800 in interest on a $15,000 equipment loan after 2 years. What was the annual simple interest rate? So we have that the interest was 1,800, so I'll put that on the left of my equation. We have that the principal, the amount invested or the amount taken out, was 15,000. So that's going to be my principal here. We have that the time was years, and it was 2 years. I emphasize that it was years because we're going to use the word annual in a second, where that's going to make it clear that I'm allowed to plug in this number 2 here. So it says, what was the annual simple interest rate? So we can go ahead and make a note that annual means our is in per year. Okay, the word annual means per year or yearly. Okay, so the fact that the R value we're solving for is annual or per year means that the years for our time is a good measure. So we can go ahead and just put R here, and we're going to have to remember to convert R to a percentage at the end. So we can go ahead and solve for this R value. We have 1800 equals 15,000 times 2 is 30,000, and then R. So if we divide both sides of this equation by 30,000, we're going to be able to get our R value. So we have right here 1800 divided by 30,000 gives me 0.06. And so we just then need to convert 0.06 is 6% per year. So the annual percentage rate is 6% per year. All right, that is our lesson on simple interest. And please make sure that you have this one down before we start talking about compound interest and other financial terms, because everything after this is going to build on this lesson. So make sure that you have these ones down, because moving on before you have simple interest understood is going to make life a lot harder. And the most important thing you can take away from this lesson, by the way, is the importance of turning percents into decimals. Okay, we never use percents in these problems. We always use the decimal format. So just make sure whenever you see a percent that you are always converting to a decimal, and then you should be on the right track. See you guys next time.